Hello everyone, welcome to the new video. So in this video we are going to discuss what is epsilon and what are epsilon transitions and how to find the epsilon closures. So first one, that is epsilon. Epsilon is an empty string, okay? And as we all know, the length of an empty string is 0. And you might have a question like, why do we use epsilons and everything, right? So we use epsilons to combine two automatas. For example, we are having one automata as let it be state 1 and a, and it will be our state 2, it will be our final state, and we are having another automata such as like this. So to combine these two automatas, we use an epsilon. So by combining, we use epsilon to combine these two automatas. So this is where we use epsilons. And coming to the epsilon transitions, wherever we use the transition using an epsilon, right, it is called as an epsilon transition. As simple as that. So next comes the epsilon closures. So epsilon closure means it is a set of all states where we can reach from the current state where the transition function is labeled as epsilon. Let us see an example to understand this. So this is the first question. So here we are having two epsilons. So the epsilon transition, sorry, the epsilon closure of Q naught is set of all states where we can reach using an epsilon. So we can also have an epsilon like this, right? We can do a self loop for everything. So Q naught, and also there is an epsilon from Q naught to Q1. So Q1, and all from Q1 you can also go to Q2. So from here there's an epsilon and also an epsilon here. So Q2. So these are the epsilon closures for Q naught. Then epsilon closure for Q1. So epsilon closure of Q1. Q1 can also have an epsilon. So self. So that is Q1 first. And we are having an epsilon from Q1 to Q2. So we can also write Q2 here. And from Q2 we are not having any epsilons. So we'll close this set. And the third one is epsilon closure of Q2. So in epsilon closure of Q2, only Q2 is having an epsilon transition because we can do a self loop here, and there are no further epsilons, so only Q2. This is how we find the epsilon closures. Let us solve another problem where we will find our epsilon closures. So this is the second question. We'll find epsilon closures for this. So first one, epsilon closure of Q naught. So epsilon closure of Q naught is we can do a self loop with epsilon. So Q naught first, and there are no epsilons from Q naught, so only Q naught for Q naught. Next, epsilon closure for Q1. So we can have a self loop for a Q1. So epsilon here. So we'll write Q1, and we are having one epsilon from Q1 to Q2. So Q2 can also be included. So Q2, and from Q2 we are having no epsilon transitions. So we'll close it. The last one is epsilon closure of Q2. So Q2 can have a self loop of epsilon. So Q2. And we are not having any further epsilons, right? So only Q2 here. So this is how we calculate the number of epsilon closures for a given state. Thank you.